Hello everyone and welcome back to the channel. I'm South 2025. Today we are diving into a game changer for character animation, Wan 2.2 Animate. If you've worked with video-to-video workflows before similar to Vase, you'll find this feels familiar, but the results are on a completely different level. We're talking about significantly better temporal consistency and much more fluid motion compared to older methods. It effectively eliminates that boiling effect we often see in AI video, keeping your character's details locked in across every frame. Before we jump into the workflow, we need to handle some housekeeping. First, make sure your ComfyUI is up to date. If you've updated very recently, you might be fine. If you found error, you could always update later and try again. Next, we have a specific list of models to download. First, for your checkpoints or diffusion models folder, you'll need the Wan 2.2 Animate model itself. I use the FP8, which size is 18 GB, so in order to run it in my RTX 4060 Ti with 16 GB of VRAM, I will need to combine it with Wan Video Block Swap. Second, in your VAE folder, make sure you have the dedicated Wan 2.1 VAE. Third, for your LoRAs folder, you'll need two specific files, the Wan Animate Relight LoRA and the Litex 2V LoRA. These are crucial for getting the lighting and depth to look natural with less step. Finally, don't forget your clip vision and text encoders. I've placed all the direct download links in the video description below so you can grab everything you need in one go. Once those are in place, we're ready to start building the graph. The next part is to download Kijai Wan Video Wrapper. There is a tutorial about how to install it in video description. The simple way is just to simply go to Manager, search for it, and click Install or try Update. Also, we need Wan Animate preprocessor. Since it's quite complicated to explain this, please refer to the video tutorial link on video description for more information about Wan Animate preprocessor. Now let's start building the actual workflow. First, we need to bring in the Wan Video Model Loader. From the drop-down, select the Wan 2.2 Animate model you downloaded. I use the FP8 version. For the attention mode, if you have it installed, I highly recommend selecting Sage Attention for the best performance. If not, just stick with SDPA, it's the reliable standard. Also, if you have Triton installed, go ahead and add the Wan Video Torch compile node and connect it directly to your model loader. It'll give you a nice boost in generation speed. Next, let's handle the LoRAs. Add the Wan Video LoRA Select Multi-Node. We're going to use two slots here. Set LoRA 0 to the Wan Animate Relight LoRA and set LoRA 1 to the Litex 2V I2V LoRA. For that second one, the Light LoRA, set the strength to 1.2. Make sure Merge LoRAs is turned OFF. Then, simply add the Wan Video Select LoRAs node and bridge your model and LoRA stack together. Now, to make sure we don't run into any VRAM out-of-memory errors, especially if you're working on a mid-range card, we're going to set up some memory management. Add the Wan Video Block Swap node. I usually set this to swap 30 blocks with a prefetch of 1. Follow that up by adding the Wan Video Set Block Swap node to finalize those settings. Finally, to keep our workspace clean and easy on the eye, we're going to use a set node for our processed model. I'll name this one My Model so we can easily call it up later in the workflow. Next, we're going to add our reference image. This is the source image for the character you want to animate. You can use a standard load image node or any other image loader. In this case, I'm using a load image path node. To make sure the dimensions are compatible, connect that image to a resize image v2 node. It's important to set the divisible by value to 16. This allows the node to automatically adjust the width and height you've set so the model can process it correctly. Once that's done, connect the width and height outputs to a set node. I also like to set the reference image itself to keep things clean. For the next part, we need our text encoders. We're going to use the Wan Video Text Encoder cache node. This is a great choice because it allows us to load the encoders and input our prompts at the same time to create our text embeds efficiently. Next, we need to bring in the vision component. Add a Load Clip Vision node to the graph. Once that's ready, add the Wan Video Clip Vision Encode node. Connect your model to this node and then take your reference image and connect it to the image 1 input. This generates our clip embeds, which help the model understand the visual identity of your character. Now that we have those, we're going to add the Wan Video Animate Embeds node. This is where motion is created. Connect the clip embeds and your reference image into this node. For the VAE input, go ahead and add the Wan Video VAE loader and connect it to the stack. Finally, for the width and height, we're going to pull the dimensions directly from our reference image after the resize step. This ensures our animation stays perfectly scaled to the original source. For our next input, we need to bring in our source video. Add a load video path node from the VHS suite. I recommend setting the FPS to 16, though you can adjust this to your preference. Just try not to drop it below 15 if you want to maintain smooth motion. In this example, I'm limiting the video to 160 frames. Keep in mind that while you can go much longer, your processing time will increase significantly. To keep everything consistent, we need to pass this video through a resize image v2 node, ensuring it matches the dimensions of our reference. Now let's set up the pose and face detection. Add an ONX detection loader and select your preferred model. If you're not sure which one to pick, just follow the settings I'm using here on screen. I've included links for all these models in the video description. Connect the image input here to the resized video frames. For the retarget image, use your original reference image. We'll also pipe in the width and height directly from our resize output. While we're at it, don't forget to add set nodes for the audio and frame count of the video so we can use them at the end of the workflow. Next, add a draw vit pose node to visualize the motion data, making sure to use the same width and height settings as before. To keep things organized, put the resulting pose in a set node. We'll also take the face image output from our detection node and put that into its own set node as well. If you want to verify that the tracking looks good, you can optionally add a video combine node here to preview the results. Take those pose and face images and connect them to the remaining inputs on your Wan Video Animate embeds node. Finally, set num frame as the frame count. Remember, as long as num frame larger than frame window size, the node will extend itself automatically. Now that this node is fully configured, we're ready to move on to the sampling stage. Next, we need to add the Wan Video Sampler node. This is the engine that actually generates the frames. Go ahead and connect your image embeds, your model, and your text embeds into their respective inputs. For the settings, we're going to use a fast, high-quality configuration. Set the steps to 6 and the CFG to 1. For the scheduler, I recommend using DPM++ SDE. This setup is incredibly efficient for the Wan 2.2 architecture. Now let's take a look at the initial results. Honestly, it's a bit underwhelming. You'll notice the character looks a bit distorted, almost like they are being forced to fill every inch of the screen, which loses the natural composition of the original reference. To fix this, we can try adding padding to the preprocessing stage. I've run a few tests here so you can see the difference. Here is 16 padding, 48 padding, 0 padding, and 60 padding. While the padding definitely helps the character fit the frame better, the overall result still isn't quite at that perfect professional level yet. But don't worry, this isn't a fault with the Wan Animate model itself. It's actually down to the limitations of the standard preprocessing we're using today. Masking will help a lot. We will also talk about it in the future. Because I want you guys to get the absolute best out of this model, we're going to take this a step further. In the next video, I'm going to show you how to swap this out for a mimic motion preprocessor. It handles body mechanics and spatial awareness much better, leading to much more realistic results. That's it for the basic setup. I hope this helps you get your first Wan 2.2 workflow up and running. If you found this helpful, please hit that like button and subscribe to the channel so you don't miss the next part where we perfect the motion. All the links for the models and nodes used today are in the description. Thanks for watching. I'm South 2025, and I'll see you in the next one.